Good afternoon. Here's college algebra test number 4, module 4, exam review, which covers chapter 7 and 8. Chapter 7 is about systems of linear and nonlinear equations. Chapter 8, analytic geometry. And here's chapter 7, systems of linear and nonlinear equations. That's what we are going to cover. All right, if the system of linear equations results in two parallel lines, the system is. It's an inconsistent system, which means the system has no solutions. The graphs are parallel lines. They have the same slope, but different y-intercepts. Here's an example. You can see they have equal slopes, different y-intercepts. And if you were to solve it by substitution or addition, you would end up with a contradiction such as 0 equals 7. So the system is inconsistent. If the system of linear equations results in two intersecting lines, the system is, in this case, it's a consistent system with independent equations. The system has a single solution. At the point of intersection, the graphs are different. They have different slopes. All that matters is that the slopes are different. They intersect, and point of intersection is a solution. And if the system of linear equations results in a single line, the system is consistent system with dependent, that's the key, dependent equations. Sometimes they just call them dependent. The system has an infinite number of solutions. The graphs are identical. They have the same slope and the same y-intercept. So if you solve them for y, they become identical. They have equal slopes and equal y-intercepts. And if you solve them using the substitution or addition, you end up what's called an identity. As an example, 0 equals 0 or 5 equals 5 and things of that nature. We want to solve the system of equations, so we can use various methods. In this case, if we use the addition method, we notice, for example, if we want to get rid of the x, we can multiply this one by 5. And if we multiply the first one by 5, this becomes minus 5x plus 10y equals negative 5. It so happened that it gets rid of the y also. When you add up the left side, these two cancel each other, these two cancel each other, you end up with 0. But the right side is not 0. 0 equals some other number. This is a contradiction. That means it's false. That means it's no solutions. So what we are dealing with here, it's a contradiction. Which is an inconsistent system. Simply put, you have two parallel lines. For the next one, if I want to get rid of the x, since they have different coefficients, I can multiply this one by 5, let's say this one by 2. If I want to get rid of the y, I can multiply this one by 3 and this one by 7. So it depends which one you want to get rid of. You make a decision and you do so. So for example, if I multiply this one by 3, I get 6x minus 21y equals 9. If I multiply this one by 7, this whole equation, meaning both sides, I get minus 35x plus 21y equals 49. And now notice they cancel each other. We can add up these two and we can add up these two. So negative 29x equals 58. And when we divide by negative 29, x becomes negative 2. You choose one of the equations, for example, the first one, and you plug in. So if you plug it into equation 1, you get 2 times negative 2 minus 7y equals 3. This becomes negative 4. Move it to the other side, becomes 7. And when you divide by negative 7, y becomes -1, and we write them as a pair. You should always check. Since we used equation 1, we must put it in equation 2. -5 times -2 is +10. 3 times -1 is -3. They do add up to 7. You must always check your work. So substitution, addition method. We can also use matrices. So what is a matrix? A matrix is defined as a rectangular array or table of numbers. A matrix with m rows and n columns has a dimension of m by n. So we have 1, 2, 3, all the way to m rows, 1, 2, 3, all the way to n columns. And when m and n are the same, it's a square matrix. A square matrix has the same number of rows as columns. The dimension would be n by n. We could add matrices that are of identical dimensions. For example, these two. So 5 and -4 I can add as an example. I can add these two and I get 1. I can add these two and I get 0. I can add these two and I get 16. And I can add these two and I get 6. This is how you add them up. The product is a different story. The product of AB of an M by N matrix A and an N by K matrix B is M by K. So if you look at the first one, the number of columns, of the first one must be the same as number of rows of the second one, or it doesn't work. If you can see here, 1, 2, 3. So what we have, in fact, let me just write this. This is a 2 by 3 matrix. This is a 3 by 2 matrix. Therefore, we can do the multiplication. And the way it works, you multiply this one by this one, and you put it as the first entry. So for example, this entry would be -3 times -6 plus 4 times 2 plus 2 times 3. These two. -3 times -6 is 18. 4 times 2 is 8. 26. 2 times 3 is 6. 32. So the first entry is 32. And I can multiply this one by this one. -3 times 4, 4 times 3, 2 times -2, and I get -4. Okay, so, and now if I use this one, multiply by this one, I get this one. I multiply this one by this one, and I get this one. So I hope you see, as long as you get 2 of them, you can see the concept. Now, therefore, we can use a calculator if need be for something which is complicated and solve. For example, how do we enter a matrix? We go with the matrix editor and we use the arrow key and we put the dimension and we put all the entries. And if you go with REF, row echelon form, you can solve it. So what I want to quickly show you is to look at the same question we had here and do the math. To do that, we are going to go with what is called an augmented matrix. So what is an augmented matrix? You just write the numbers. What numbers? Coefficients. So coefficient of x is -1 and 5, -1 and 5. Coefficient of y is 2 and -10. And on the other side, you can put some line and put -1 and 6. So again, -1, 5, 2, -10, -1 and 6. This is how you write the augmented matrix here. Now, I'm going to quickly show you by hand how we do that. But ultimately, when it gets involved, you can always use a calculator. And so to do so, the idea is that you want to make the very first entry 1, everything underneath 0. Then diagonally, you want to make this one 1 and everything underneath 0, so on and so forth. This is called the echelon form, okay, or row echelon form. So in order to make this 1, all I have to do, multiply this one by -1. By the way, you have to do a row transformation, which is acceptable. Remember, this represents this equation, and this represents this equation. So this equation, can I multiply both sides by any number I want? Yes. So if I multiply by negative, in other words, negative R1 replaces R1. This becomes +1, -2, +1. So my goal was to change this to 1, and I got it. Now, the next goal is to put everything underneath 0. So there's only one of them, but even if there were more, I would do that. How do I make this 0? There may be different ways of doing it. One way is to subtract 5 times of this row from this one. Again, remember what you're doing. That means you're multiplying this one by -5 and you add it to this. That's the concept. So if I multiply this one by 5 and -5, if you will, and add it to the second row, let's see what happens. For example, here, -5 times 1 with 5 becomes 0. -5 times -2, +10 with -10 becomes 0. -5 times 1 becomes -5, and 6 becomes 1. So the new row is 0, 0, 1. So I hope you realize what we did. We multiplied everything here by -5, and then we added it to the second row. Now, as you can see, the final row indicates that the system is inconsistent and has a solution set. This is called phi an empty set, because you can rewrite this in the following manner, class. This is the same as writing x minus 2y equals 1. And this is the same as writing 0 times x plus 0 times y equals 1. And this means 0 equals 1, which makes it inconsistent, which makes it having no solutions. And as I mentioned, you enter the matrix in this fashion using the matrix editor. Put all the entry, and then you solve it. So here's matrix A, and we chose it to be 2 by 3, and we put -1, 2, -1, and then 5, -1, 6 here. So we put this one into matrix A. Then we command REFA, we enter, it gives us this one. And right here, you recognize exactly what we got here. And that's the idea. When sometimes they may slightly look different, but the fact that all entries are zeros except the last one, okay, makes this an inconsistent system. Now we want to solve this system. We've already done that. So let's put this into augmented matrix. So we come up with a matrix column 2 minus 5, 7, minus 7, 3, and 3 and 7. So I hope you can see the augmented matrix 2 minus 5, minus 7, 3, 3, 7. And we have a line here which separates this matrix from the solution matrix. All right. We want to make sure this is 1. We can divide everything by 2. But the problem is it creates a fraction. Can we do that? Absolutely. Should we do that? Normally, we should avoid dealing with fractions. So with that being the case, how do I make this one using that? If I multiply this one by 3 becomes 6, and if I add this one to it, becomes 1. So I'm going to say 3 times this plus R2. So 3 times 2 and minus 5 becomes 1. 3 times this, 3 times negative 7, negative 21. Add 3 becomes minus 18. 3 times 3, 9. Add 7 becomes 16. Okay. So I hope everybody is clear. So as an example, minus 7 times 3 minus 21 and 3 becomes minus 8. So we achieved the first one. Now the next step is to make this guy 0. And to do that, let's just write the first row unchanged because we don't want to change that. This is the one we are going to change it to 0. Okay, so let's see how we do that. Again, there may be different ways. One easy way, if I multiply this one by 5 and add it to this. So I'm going to write 5R1, that means 5 times row 1, plus R2, row 2. So if I multiply this one by 5 and I add it to this one, I get 0. If I multiply this one by 5, 5 times negative 18, 5 times negative 18 is negative 90. With 3 becomes 87. If I multiply this by 16, I get 80. With 7, I get 87. And this is what I want to discuss as far as row echelon form and reduced row echelon. As far as the row echelon form is concerned, I can write this as x minus 18y equals 16. This one is 0x minus 87y equals 87. And if you divide this one is, if you divide by minus 87, y becomes negative 1. You put it in here and you get x. So that's not a big deal. But I want to show you as far as the matrices are concerned. And by the way, to change this to a 1, all you have to do is say this is the second row. So you can say row. So we are going to show you quickly, maybe right here. So I'm going to write row 2 divided by minus 87 is the new row 2. So the first row is unchanged. The second row 0, 1, negative 1, and there you have it. This is the row echelon form. So you put the matrix in the augmented matrix. Is this one you put it in? If you go with REF on that, you get the same thing that we have here. Take a look, which means y equals negative 1. Now again, they may not look like what we have here because, as I mentioned, if you use fractions, it's actually faster, but maybe you want to avoid that, okay? Either way, it makes no difference. You have this one, and now you play, this is x minus 0.6, y equals negative 1.4. You replace this is the y, okay? This represents the y because the second one is 1. And then you can plug it in and find x. Or instead of REF, if you do REF, this is row echelon form. This is reduced row echelon form. What it does, the main diagonal becomes 1 and everything else is 0. So Because everything else is 0, that means this represents x, means -2. This represents y is -1, and that's exactly what we have here. So if you go with that, it gives you the solution in one shot. Again, to quickly show you, so we go with a matrix editor here. So I go with second and x to the power of -1. So I go to edit, and the moment I edit a part A, now it gives me a chance to put the number of rows, 2, the number of columns, 3. Okay, let me go back up. I thought I put 3, but I didn't. And so now the first entry, as you can see, is number 2 here. So I'm going to put 2, enter, -7, enter, 3, enter, -5, enter, 3, enter, 7, enter. So I've got my, this is the matrix that I was looking for. I have it here. Okay. Now I go to matrix editor. I go to math. And I bring the arrow down. REF, if I click on REF, matrix A should do the answer. So I then put the parentheses, I think. Again, I put, let's put the parentheses here. And now this is the same matrix that we had here. If we do our REF second, math, and again, so second x to the power of -1, math, and we're going to bring it down to our REF this time. And again, second, this is matrix x to the power -1 makes it matrix, and A, and a parentheses. See, I needed the parentheses last time. And now it gives me the same answer as here. So I'm showing you how to work with a calculator as well. So we finished that. All right, let's quickly look at both methods, again by hand and by using a calculator. It's a 3x3. So let's give them a name, equations 1, 2, 3. So we can refer back and forth. You have to decide which variable to get rid of, and you really have to choose wisely because some of them are easier than the other one. For example, you notice that these two can cancel each other. And so simply put, if you add these two, this one and this one cancel each other, these two, equation 1 and equation 2, you get 5x plus 3z equals 1. So equation 1 and equation 2 result in that. Now, what matters is that since you use the first equation and second equation to get rid of the y variable, now the one which hasn't been used is number 3, must be used with one of the two, it doesn't matter which one, and you must get rid of the same variable, namely y, because we have 3 variables, we want to go to 2 variables. Okay, so equation 4 is the combination of 1 and 2. So for example, equation 3 hasn't been used. If we use it with equation 1, this one we can multiply. This is minus 4, this is 3. I can multiply this one by 3 and this one by 4. If you multiply this one by 3, you multiply both sides, you get 9x minus 12y plus 6c equals minus 45. And if you multiply this one by 4, you get 8x plus 12y plus 20z equals 80. And now these two cancel each other. They add up to 17x, 26c, 35, and we give it the name equation 5. So equation 4 and equation 5, we put them next to each other, and they have x and z only. You can get rid of any of them, it doesn't make any difference. If we want to get rid of the x, we can multiply this one by 17 and this one by 5, by negative 5. So let's do that. You multiply by 17, you get 85x plus 51z plus 17. You multiply this one by negative 5, you get minus 85x minus 130z minus 175. These two cancel each other, obviously. And so they add up to negative 79z, they add up to negative 158. If you divide by negative 79 both sides, you get z equals 2. In other words, now you can go to either equation 4 or 5 to find x. For example, equation 4, 5x plus 3 times 2 equals 1. That means 5x and 6 is 1. 6 goes to the other side, becomes negative 5. So this class goes to the other side, becomes negative. Add up to negative 5, you divide by 5, and x becomes negative 1. Now you have to go to one of the original equations. It doesn't matter which one. For example, the first one, 3 times negative 1 minus 4y plus 2 times the 2 gives you the answer. 3 times negative 1 minus 4 times y plus 2 times 2 equals negative 15. This is negative 3 and 4 becomes positive 1, goes to the other side. So I'm assuming everybody can see that this is negative 3, this is 4, and they combine to positive 1 goes to the other side, becomes negative. There you have it. Now, what is important now is checking. Look at this one. This was equation 1. Now you must check with equation 2 and 3, and it doesn't take long before you can check whether you made a mistake or not. Now, for a case like this, you may want to use matrices. So the augmented matrix has 1, 2, 3 rows and 1, 2, 3, 4 columns. So you put 3, 2, 2, minus 4, 4, 3, 2, 1, 5, minus 15, 16, 20. This is the augmented matrix. Okay, it can't show it here, but when I go to the next page, it can show you this. There wasn't enough room to show that. So I call this matrix matrix B. I put this in matrix B. Now I'm going to do REF on B. If I do that, What happens is that this is the last one, everybody. And so that means z equals 2, and then you have to figure out the rest of them, okay? So this one is 1, and it's minus 0.5 equals 3.9. So you can find it, but we can change those to fractions so it shows the whole thing. I want to show you this. If you, instead of decimals, go with fractions, and all you have to do, change the answer to fractions. Look at this. So this is the original augmented matrix. You know, we can't see it here, but you get the picture. And this is the augmented matrix we just made up. And so if you look at this very last row, this means, see, 0x plus 0y plus 1z equal 2, therefore z becomes 2. Now this means 0x plus 1y minus 1 over 20z equals 39 over 10. This means 1x minus 4/3 y plus 2/3 z equals minus 5. And so you can solve it now on your own. But if you go with, instead of REF, you go with RREF, this last column is the answer as we have it. Yeah, of course, we would go with RREF, but I hope it's clear to everybody as to what's going on. All right. So that's the answer. All right, again, you can use the process, but in some cases, it's pretty easy to see what happens at this point. If I multiply this one by 8, by the way, if I were to write the augmented matrix, would be 1, 0, 0, 1, 2, negative 16, 1, 3, negative 24, and those numbers, okay? So if I multiply this one by 8, I get 16y plus 24z equals negative 112. And as you can see, everything cancels out on the left side. So you get 0. But on the right side, you get some number. And it is negative 224, but it doesn't matter, some number. The point is these two are not equal. Therefore, it's false. No solution. If I want to solve this by addition method, if I multiply the top by 3, I get minus 3x minus 9y and minus 6. These two cancel each other, these two cancel each other, these two cancel each other. So 0 equals 0, which is a true statement. And that means it's an identity. That means you have actually the same equation. You have infinitely many solutions. And one way to write it, they write x and they solve for y in one of them, it doesn't matter, and they put it as the solution. Instead of writing x comma y, the y is a function of x, so you solve for y, move the negative x and divide by negative 3. Now, if you were to do this by matrices, here's the A matrix, minus 1, 3, minus 3, 9, minus 2, 6, and if you do REF, all zeros at the end means you have a dependent system with infinitely many solutions. Let me just make a note of a dependent system, everybody. Dependent. Have a dependent system. All right. Let's go with solving this equation. We are looking at a system of equation involving nonlinear equations, and we can solve it in the same manner. If you just add them up, since these two cancel each other, if you just add them up, these two cancel each other, we get 4x squared. We get 28. Just add them up. I can divide by 4. And I get 7. So x becomes plus minus square root of 7. Now I go to one of the equations, for example, equation number 2. Okay, I'm going to call this number 1. It's easier with number 2. And I'm going to plug in x. And by the way, because it's x squared, it doesn't matter I put positive square root of 7 or negative square root of 7, it gives me the same answer. And I hope you realize this is 7 plus y squared equals 16. So y squared becomes 9 and y is plus minus 3. It's important to know how to write this, which results in 4 answers as follows. And you can pick any of them and check if you have doubts. Put this one in both, put this one in both, this one in both, this one in both. And you can do that, or just check with equation number 1, because this comes from equation number 2. Okay, check with only one equation, equation number 1. We want to graph the system here. And so when you're dealing with a system of linear inequalities, first you want to find the lines. So let's set this equal to 2 and let's set this equal to 6. All you have to do, graph this, and we can find the intercepts. This one, if x is 0, y is negative 2. If y is 0, x is 1. This one, if x is 0, y is 3. If y is 0, x is 2. I'm assuming everybody can come up with the intercepts nice and easy. And so we graph the two lines. Okay. So the red line, 0, negative 2, 1, 0. Here's the line. The blue line, 0, 3, and 2, 0. And when we go back before we continue, this has an equality, that means a solid line, but this has an inequality, that means a dashed line. So the red one becomes a dashed line. So the first thing I do, I write the equation of a line next to each one. Then I make it a dashed line. I can't emphasize this enough. So let me write this is a dashed line, okay? Because we don't have the equality. That means that's not part of the solution. The line is not part of the solution. Now you pick a test point. The easiest test point would be 0, 0. And so you test this for this line and you test this for this line. So you write them here. For example, if I put it here 0 and 0, 0 is less than 2, this gives me a true statement. So for the red line, this was the red line, remember, this is a true statement. So this side is the solution. So if I were to shade a region, would be this side. For this one, when I put 0, I get 0 larger than or equal to 6, which is a false statement. For the blue line, this is not the answer, it's the opposite. So take a look. This becomes the answer. So look at this versus this, and this becomes the answer. So this is how you shade it. If you can shade it with two different colors, clearly this is the answer. If you can't and it becomes hard to see, this would be the answer. Graph the inequality y equals x squared plus 1. Y equals x squared plus 1. First, we graph y equals x squared plus 1, which is y equals x squared, and it moves up by 1 unit. So it means this is a parabola of y equals x squared, has gone up by 1 unit. So this one has coordinates 0, 1. Now we can pick a test point. That means somewhere inside or outside that. For example, if I pick 0, 2, that means I'm checking this one. If it's a true statement, I shade the inside. If it's false, I shade the outside. So I put the 0, 2 into the original inequality. I replace the x with 0. Y, which is 2, is larger than 1. Yes. Therefore, I shade the inside. So that's the answer. A chemistry lab assistant wants to prepare 10 liters of 48% acid solution. In stock, it's got 80% and 40% acid solution. How many liters of each in stock solution should he mix to prepare a 10-liter mixture? So we have to come up with a table. We have 80% solution, 40% solution. We want to mix the two. And so whether you write this or not, you can keep it as 80% or 0.8 versus 0.4. And when we mix them, what do we get? 0.48 or 48%. So these two, you can right here put 48% of 0.48. That's it. Now, as far as the volume is concerned, we don't know the volume for each one. So if we go with the system of equations, the volume for the first one is missing, for the second one is missing, but we know that they add up to 10 because we want 10 liters of the mixture. So the total is 10. How much of each, I don't know. How about X and Y? And now X and Y must add up to 10. That's one equation. Now, when something is 80% acid, that means the pure amount or the actual amount of acid is the product of the two. The rest is not acid, normally it's water. So 0.8X here, 0.4Y here. And the product of these two, 0.48 and 10, goes here, which is 4.8. And so this is one equation. This is the second one. You can do it by any method. For example, if you do it by the substitution method, you can solve for Y by moving X. And now replace the Y with 10 minus X in this equation. So we have 0.8X, we distribute, we get, by the way, you can multiply both sides by 10 to get rid of the decimals, but this is fine, and I'll show you that one in a moment. So this gives you 4, this gives you minus 0.4X, this doesn't change. And now this 2 add up to 0.4X, and we are going to subtract 4, and I get 0.8 divided by 0.4 gives us X equals 2. And if X equals 2, Y must be 10 minus 2. So we write 2 liters of 80% solution, 8 liters of 40% solution. Now, if I multiply this one by 10, multiply by 10, I get 8X plus 4 times 10 minus X equals 48. And I can solve this one, and it gives us the same answer. It's, if anybody finds it easier, you can go that route. How many liters of a solution that contains 15% chemical must be mixed with 6 liters of solution containing 10% chemical to make 10 liters of solution containing 12%? So again, we have pretty much the same type of table, 15% or 0.15, 10% or 0.1. When we mix them, we want 12%, 0.12. So 15% solution, if we go one by one, how many liters of a solution containing 15% chemical must be mixed with 6 liters of 10% chemical? Okay. 10%, right, 0.1. To give us a 12%. And those are the given ones. How much do we need here? How many? How about X amount? When we mix them up, and that's why it's called a mixture problem, because they add up. X plus 6. And the pure amount is the product of these two. 0.15 times X goes here. 0.1 times 6 goes here. 0.12 times x plus x goes to the last. And since we just used one variable, this gives us the equation. Add these two and gives us the last one. This is 0.6. This is 0.12x. This is 0.72. And we move this here. We move this here. We get 0.03x equals 0.12. We divide by 0.03. Which is the same as 12 over 3. Or x is 4. So we need 4 liters of 15% solution. To take care of the business. So how many liters? 4 liters. Now a plane can travel 800 miles per hour with the wind and 720 miles per hour against the wind. Find the speed of the wind and the speed of the plane. We want to set up an equation. So first we're going to define our variables. Plane, the speed is P, the wind is W. I sometimes use the initials, because it makes it easier. So with that being the case, when we go with the same direction as the wind or current, the speed of the wind and the current will help us, and against it will work against us. So this would be P plus W, this would be P minus W. And there's really not much you have to do, just add them up. These two cancel each other. 2P equals 1520, just add them up. And divide by 2. The speed of the plane becomes 760 miles per hour. Put it into the first, and W becomes 40, or the second one, it makes no difference. Make sure you check and recheck. Admission tickets to the Braden River Little League All-Star game cost $4 for adults and $1.50 for children. A total of 225 tickets were sold and a total of $500 was collected. How many adult tickets and how many children tickets were sold? We want to set up a system. So adults tickets cost, number, total, children, and total. So let's plug in what we have. So it's going to cost $4 for adults, $1.50 for children. We have a total of 225 tickets, number, total is 225. And then we collect total of $500, total amount. So these are the given. So how many adults? Again, you can go with X and Y, but I'm going to go with A, and for children C. So I'm going to use the initials. Again, you don't have to. You have to use either what they tell you or choose your own. So now the product of these two is the total amount. For A, $1.50C. So A and C, they add up to 225. This is one equation. 4A and 1.5C equals 500. This is the second equation. And you can choose by any method. For example, if I multiply this one by -4, I get -4A minus 4C equals -900. If I add equation number 2, these two cancel each other. These two become -2.5C and these two -400. So again, I'm adding them up. These two cancel each other. And this is the result. Divide by -2.5. Or you can say 4,000 over 25. Remember, negative over negative is positive. The answer is 160. So if this is 160, you're going to subtract it from 225, that's 65. And it's important to know that I use this one to get the missing a. So now you have to check with this equation to make sure you have it right. All right. One leg of a right triangle is 4 centimeters less than the other one. The area is 70 square centimeters. Determine the length of each leg. We want to set up a system of equations. First and foremost, this is a right triangle and it may not be to scale. This is X amount, this is Y amount, and we know the area is 1/2 base times the height. And as you know, with the right triangle, the legs, one of them is the base, one of them is the height. Okay. So one leg is 4 centimeters less. I look at the very first center, X seems to be smaller. So X is Y minus 4. And then the area 1/2 base times the height, 1/2 X times Y is 70. So I hope everybody can see the two equations. So this is the first one, and this is the area. So because we don't like the fraction, let's get rid of that. So multiply both sides by 2. And let's do the substitution. X is Y minus 4. I can replace the X here. And so I get Y squared minus 4Y. Y squared minus 4Y. I'm going to move the 140. The reason I bring everything to the same side so I can factor. I want two numbers. The product is 140. The sum is -4. -14 and +10. This tells me Y is 14. This tells me Y is -10. As you know, sides, dimensions can't be negative, so -10 is out. So Y must be 14. What is X? 14 minus 4 equals 10 centimeters. Is this right? Well, what is the area? This number times this number times 1/2. Is that equal to 70? Yes, we just checked. So we have the dimensions. I hope everybody is comfortable with that. The sum of three numbers is 105. The third is 11 less than 10 times the second one. Twice the first is 7 more than 3 times the second. Find the numbers. Now, first and foremost, you want to define your variables, okay, before even you move on. So we let the first number be something, the second one and the third one. Let's go with X, Y, Z. You can go with A, B, C, or anything you want, but define your variables. So here's my first number, here's my second number, here's my third number. The sum is 105. So that's the sum. X plus Y plus Z equals 105. X plus Y plus Z. That's the first sentence, and I put it in blue. The third is Z equals 11 less than 10 times the second. So 10Y minus 11. So the second equation in red. Twice the first, that means 2 times X. Twice the first is, that means equals. 7 more, 7 plus. 3 times the second. 3X. This is 3X, everybody. This is the most important part, understanding what is given. So let's call them equations 1, 2, 3, again, so we know what we are dealing with. Again, you can use any method. You can also use matrices. So in the first equation, we have X plus Y plus Z, and Z is 10Y minus 11. So if I just use a mixture of substitution addition, I put the Z equal to 10Y minus 11. I replace the Z with 10Y minus 11. What happens when I'm done, it has only X and Y. So this is X, this is 11Y, and move this to the other side, becomes positive 11, and 105 is 160. I'm going to name it equation number 4. Equation number 4 has X and Y. Okay. This was Y. I thought I put Y. My apologies here. Okay. So as you can see, the third equation also has Y. So we put equation number 3 and equation number 4 next to each other. And now we have a system involving 2 variables and 2 variables only. So we can solve, we can get rid of one of them. So since this is 2x, here's again a slightly different method, mixture of substitution addition. Since this is 2x, I can multiply this one and change this to 2x. So 2x and 22y is equal to 232. And now this 2x, I can replace it with 7 plus 3y. See? Now I'm going to, instead of solving for x, it's easier this way, believe it or not. I put 7, again, I wanted to show you different methods. This is not the only method. You can choose any method you want. I'm going to change the 2x to 7 plus 3y. Okay. And so 3y and 20y is 25y, subtract the 7. So first thing first, we're going to move the 7 and subtract it from 232, which gives us 225, and these two add up to 25y. We are going to divide both sides by 25, and y becomes 9. Since we have to check with the original equations, and it's easy to see that z is 10y, so 10 times 9 minus 11. Let's find the z first, which gives us 105, which gives us 79. And then x plus y plus z is 105, which gives us x equals 17. And I like to write them in order. And you can check and recheck to make sure you're in good shape.